Okay, YouTube indicates it's receiving data. I'm going to go to single broadcast. Hopefully we're single broadcast. Okay, it is February 19th. February 19th. It is Friday, and we are getting ready to do class today. Wow. All right. Tools are all moving at crazy different places for me today. All right, so let me just get settled here. Is everything okay? My light's on, I'm broadcasting. Can someone in game confirm via audio that everything looks like it's broadcasting okay? Okay, great. All right, so let's take a look at the calendar for today. Today is February 19th. We are working on chapter 7 today. Let's look at that in a second. Let me introduce Chapter 6 programming assignment, which is due Monday, which I know is fast, and I know that you all have a lot of work that you've been doing for this class. I appreciate it. Starting chapter, okay, let's look at Chapter 6 first, and let me explain what's happening, then we'll give you a little bit of context for that. Chapter 6's programming assignment is I would say a little bit more fun and a little more simple than the quadrilateral one was. I think the quadrilateral one is challenging, but I'm not exactly sure I'd say it was fun in the way that most people would describe fun. Chapter 6's programming assignment is going to be about using the JMonkey engine in order to make a pyramid. Now, the goal of this programming assignment is to work with loops. And so the way that I'm going to ask you to work with loops is to create a pyramid of blocks in JMonkey Engine. So what you see on screen and what is in the Canvas assignment is a simple video that shows a pyramid of 4 blocks. There are 4 on the ground and one that's balanced on top, although there's no physics engine here, so it's just being placed there to make it look like it's balanced. What I'm asking you to do for the assignment is to modify this pyramid so that it contains at least 150 blocks. And the point of that number is to make sure that it's large enough that it is not worth your while to do it manually, because what I want you to do is I want you to do it with loops. So the way the loops are going to work in this world or in this code is that you're going to write loops that in the body of the loop places a block at different locations in the world. The way in which you're going to get the pyramid structure is by using the indices of the loop, using loop counters as coordinates or as the basis for calculating coordinates for your pyramid. In order to do this, you're going to need to use nested loops. If you just used one loop and you were to make blocks with one loop, you could create a line of blocks, a linear set of blocks that are in a line. In order to get a grid of blocks, a two-dimensional grid of blocks that's laid out like maybe a spreadsheet or a sheet of graph paper, to do that, you would need a doubly nested loop, a loop within a loop. The inner loop would travel along the x-axis maybe, and the outer loop would travel around on the y-axis so that you could fill out a complete set grid of blocks. In order to additionally add height to this pyramid, you're going to have an additional nested loop. To create a volume of blocks, to create a three-dimensional grid of blocks that looks like maybe, what would that look like? Like maybe a Jenga tower is a good analogy. To get something that looks like that, you would need 3 nested loops, one for each dimension. The outer loop maybe would go x, the second loop would go y, and the inner loop would go z. So basically, that's what I'm asking you to do, is to create a 3-dimensional structure of blocks, but to adjust the way in which you're making them such that it creates a pyramid in that process. Now you have a little bit of flexibility here. What exactly a pyramid is open to a little bit of interpretation on your end. So provided that you're using loops and nested loops, you have a little bit of freedom to do what you want with the pyramid. One thing that you don't have freedom to do, though, is to change the texture of the blocks, because I'm asking you to just submit a file, which is one class, pyramid.java. So you only get to submit one class. You don't get to submit a whole project. So you can't add, for example, asset files that would contain a new texture. So focus just on the shape of your pyramid, and it'll be composed of cubes like this one is. In order to get this thing launched, you're going to need to import a skeleton project, which there's a link in Canvas, this episteme6 skeleton.zip. And in Slack, in our class, I had a conversation about how to do that. I think it was with Sam. Let me double check that. So, nope, it was Thomas. Yeah. Okay. So if you don't, or if you aren't comfortable importing that file into Eclipse, you can go into our Slack channel under hashtag CS-030 Spring 2020. You can see Thomas asked a question about how to get that into Eclipse, and you can click on the reply in order to see the thread over on the right with the detailed instructions over here about the different menu items to select in order to bring that into your project. It looks like it worked okay for Thomas by his reply. Awesome, thank you. If you do it correctly, it should load into Eclipse, and then you should be able to execute the main method in the environment class, just like we did in our samples earlier in the semester. And it should launch this simple example. And from that, you should be able to modify the existing code, the existing pyramid.draw, to build your bigger pyramid. So stepping back, I said this should be a little bit more fun. The amount of code that you're writing here is relatively small. You know, I think you could probably tackle this with like 1, 2, 3, 4, 5, like less than 10 lines of code. Of course, counting lines of code doesn't help very much if the logic is wrong. So you could have 10 very difficult lines of code, or you could have 10 simple lines of code. So just saying 10 lines of code doesn't speak to how difficult something is. But there certainly is just not a lot of volume of code to be written for this. And hopefully, because it's in a graphics environment, you'll find it fun. And you'll also find it a little bit of a relief after working on the quadrilateral code, which I know is a big project. Okay, so I would also like to give a little bit of context about Chapter 7, but before I do that, would anyone like to ask any questions about the assignment as far as you understand it at this point? I'll go ahead and drop the link to the assignment into Slack as I'm giving you a chance to do that. So if you want to take a peek at it, you can. All right, I hear typing in Firestorm. Let's take a look. All right, look okay. Yeah, and as far as Firestorm goes, you can see I haven't gotten our attendance block working yet. So I'll continue to work on that. Okay, so let's see, rolling back. So what I've got on the screen now is Canvas, and we're rolling down, and we've been going fast through the chapters, last few chapters, because there are things like, loops and primitive types, things that are a pretty close analog to Python, and which I didn't want to spend too much time on at this point. So starting today, we're going to shift into Chapter 7. This is my view. You're not going to see this exactly. Chapter 7 is about arrays and array lists. So this is the point where we start to transition from primitive types into the Java collection framework, or the way in which Java uses objects more robustly and more deeply than it uses primitive types. And the best way that I know to transition between those two is to talk about arrays and then going into array lists. So arrays and array lists are both mechanisms for handling a collection of objects, a list of objects, a linear sequence of objects, a list from Python, same kind of data structure. But there are two different ways of doing it. One is coming from the primitive data structure world, and the other is coming from the object-oriented world. We're going to make that transition around this particular data structure. So let's take a second to connect everyone on, let's see, let's take a second to connect everyone on Saros. Frank asks in game, can someone tell me how I can show Saros block in my Eclipse? Oh, you probably mean the little window down at the bottom for Saros. Okay, so if you don't see Saros down here, the way you can do it is you can go up under Window and Show View, Window, Show View, Other. In the filter, type Saros, select Saros, and then do Open, and that'll pop up the block for you. Sometimes you get it by default, sometimes you don't. Okay, so let's go through and share Saros. Addie, you're in. I'm shifting you to read only. Ben Fernberg, you're in. I'm restricting you to read only. Landon, you're in. Restricting to read only. Matthew, you're in. Restricting to read only. And let's go through and try and add Ben D and Ben A and Carson. And let me see how progress is going there. Ethan V as in Victor. Ethan B as in brandishing a sword. Faith. I know, Faith, you're having some troubles because we were trying to do that before I showed up in world. Josh. Monty. Dee Dee. Faith, do you think it's because of your bandwidth from the place where you're taking the class? I'm a little, these are simple projects, so I'm surprised that bandwidth would be limiting here, but maybe it is. Okay. All right, we'll let those pull up together, and let me pull up our slides for today. All right. We're linking. Synchronizing in Saros. Looks like a lot of you are arriving. That's good in the sense that you're getting your code coming. Their code is synchronizing. I'm going to try and switch some of you to read only. I'm in the back of my head, what I'm wondering is if setting people to read only reduces demand on the system, since that means that information only needs to flow one way. It only needs to flow to you. It doesn't need to flow back. So I'm a little curious about that. I actually tried to download the software for Saros so that I could make some of the improvements to it that I would like to see, but wasn't able to get very far before something else demanded my attention. It's open source, so in theory you can do it. What I find a lot of times in working on open source projects means projects where the source code is free and open and available to anyone that would like to use it. One of the things that I find, though, in participating in open source software projects is that while you may understand the language and you may have some goals for how you would like to see the software changed, and while other people that are part of the community of developers that are developing that software may agree with you on those need for those changes, setting up the project can be very challenging. So just in the same way that I had to give you instructions for how to import the Episteme 6, you have to have a similar kind of conversation about how to set up the source code if you're going to be a developer. To be a developer, you have to have your source code set up in a way that if you're just running the program, isn't as complicated. So if you're a developer, you often have to have libraries set up and you have to have things linked correctly like you see us doing in Eclipse all the time. It's just that you don't have someone in these open source projects who's running the organization in the same way that I am, making it easy for people to share the project. It's more less hierarchical, so it's a little bit more challenging. So a lot of times just getting into the architecture of your program is a challenge for that. Okay, let's get started and maybe we'll give it one more shot once everything settles down. All right, so it's chapter 7, working on a new chapter. We're looking at primitive type, a kind of primitive type called an array, and then a transition into the object-oriented version called array list. It's chapter 7, so it's a new chapter, so we need an update on how Dodge is doing. Let's see if I can pull him up. Where'd you go, Dodger? All right, I just have one picture for you today. Here he is. This is a new behavior that he has that maybe isn't the most healthy behavior in the world. We call it periscoping. This is when he will hop up on my leg and survey everything that is on the table to see what it is he is missing out on. So this is him at breakfast. I think yesterday morning I was having breakfast and he was investigating what was there. He's pretty good about not eating off the table, but he's very interested in knowing what is being eaten. And so this is him checking out one of his favorites, which in this case was peanut butter. Later in the day, he got to finish off the empty jar, so he did actually win in that case. So Dodgers doing well, and we are generally doing well as well. And our friend who is at UCLA, we got an update, and she is recovering, and we got a picture of her smiling, so that's a good sign. All right, so arrays and array lists. Let's just check in if anything. Great. Faith, this is a new problem starting Wednesday. Okay, I'll touch base with you about that separately. Okay. All right, so arrays and array lists. So an array can be thought of abstractly as like a boxcar. This is what this picture is here for. This is a train with a bunch of boxcars. And each one of those boxcars contains a bunch of black rocks. We'll say it's coal. I don't know what it actually is, but we'll say it's coal. And we use this as a metaphor for an array because an array is like this as well. It consists of a number of different slots in memory. Those slots are like these gray containers. And then into those slots we can put data. And so if the coal is going into the boxcars, data goes into the slots in our array. Another reason why this is a good metaphor for an array is because this has the same properties of the linear behavior, the linear structure of an array, where you have a specific ordering of these different boxcars. And when you put data into one of these locations, that order, one boxcar being before another boxcar, is something that's maintained along the way. And so that aspect of an array is good. It's linear, it's ordered. The other thing that's good about using this as a metaphor for an array is that when you put something in one boxcar, like coal, you can also put the same thing in another boxcar. You can have several different array locations that contain the same data. It's not unique, and it's not in any particular order. And this is a subtle distinction that sometimes people who are using arrays for the first time aren't able to communicate well and aren't able to communicate precisely, even if they understand the idea. And so let me see if I can articulate this carefully. In an array, the order in which the data is placed into the different slots is maintained. So that means that if you put coal in one boxcar and you put gummy bears in the next boxcar and you put plutonium in the third boxcar, that order is maintained. But what's not true is it's not true that the order is anything like alphabetical or by height. The order is just the order in which things were placed in the boxcars. That initiation order is maintained, but that doesn't mean that the order of the data that's in the boxcar is relevant to any properties of the data itself. It only maintains its order based on the way that you put it in. If you have an array and you want to put strings in each one of your slots of your array, maybe the names of everyone in the class, one name, a second name, a third name, each one in the boxcar, the order in which you put those names in will be preserved. But the fact that they are, the order of those strings is preserved does not mean that they're alphabetical. So let me just, so we have Frank, just thinking of a few names that I just swapped in. So if we have Patterson and Frank and Faith, we can put those three elements into a boxcar and they're not in alphabetical order. And yet the order is maintained because Patterson, Faith, and Frank is the order that I put it in. Well, later on, if I decide I want the order to be alphabetic, I have to swap them around. I have to move them in position. And then, if I've placed them in alphabetic order, which would be Faith, Frank, Patterson, that order will be maintained, but not by virtue of it being alphabetic, but because I placed it in there alphabetically. All right, so that's a subtle and important distinction that when I see some of you all writing about the way that lists and arrays, dictionaries and sets all these different data structures are different, that precision is not present in your language, and it needs to be present in your language when you're talking about these data structures. It's important for being able to communicate to other developers what's happening. And also because communication is a reflection of how we think, it also reflects a lack of clarity in your own mental model about what's happening, which means that there is room for growth in your programming, understanding your mental model of programming. Okay. Okay, so there's a couple different ways that we can use these, and we're going to look at this over the course of the semester. Okay, this chapter, this week. All right, so arrays. So an array is a collection of sequence of values, and in Java, it must be the same type. So initially, when I said that my boxcar could contain coal and gummy bears and plutonium, that maybe is a violation of the metaphor, because if you consider gummy bears and plutonium to not be of the same type, you can't really do that in Java. So maybe a better analogy would be to say we have coal and quartz and clay, three different kinds of dirt. And if dirt is the type, then that makes a little more sense. The syntax of Java enables us to create an array using this kind of a syntax that you see in front of you in the yellow block, where it says new double 10. What you're seeing here is something like a proto constructor. What you're seeing is a historic legacy of the way in which we created things before there was an understanding of objects. So this is actually historically, or in the trajectory of the development of the Java language, it comes before calling a constructor. Before the Java language had solidified around this idea, and other programming languages as well, around this idea of what an object actually is. So at this point we said new because we understood that we were creating new memory, and we understood that we wanted to create a memory that would hold 10 doubles, which is what this is doing here. And then this is going to create that memory, which we then need to store in a variable. All right, so the number there is how many of that type that we're going to store, and the new operator reserves that memory for us. It actually creates it. If we want to then store that memory at a location, we want to put that in a variable, we want a variable to hold on to that so that we can use it, we have to declare the type of that variable. So the first yellow block describes how we create that memory, how we sort of initialize it. This is how we create a variable of that type. All right, so let's read this off here. What I have here is I have an array of double whose name is values. Values is just a name that I picked. It's my variable name. It should reflect what I'm planning on doing with my array. Double is the primitive type that I'm using as the basis for the array. The empty square brackets mean that the type is an array of doubles. But what you can see in the declaration of the variable values is that there isn't any indication of how much data is there, how many doubles are present. When we declare the variable, when we announce to the compiler that we want to use a variable which is going to be an array of doubles, we don't specify how many is present. That's something that's kept abstract. And when we actually work with it as a programmer, we need to keep track of it. For example, in the first block, when we declare how many we actually want, how much memory we want reserved for this thing. So when we put it together, we can both declare our variable like we have in the one here with the little blue 1. That line is a declaration of the variable. The bottom yellow box right here is a declaration of the variable and an initialization in one step. So to read this off, the way I would read this is, we're declaring a new array of doubles whose name is values, and we're initializing it with an array of doubles that is of length 10. The left side declares it, the left side of the assignment statement declares it, the right side is reserving the memory, and when we're done with this line, values is now a reference to that chunk of memory that we can now access. Using our square brackets in different ways, depending on which side of the assignment statement it's on, and then there's yet another way we're going to use those square brackets in order to get into the data. By default, each one of those elements of the array is going to be initialized to whatever the base value is for that primitive type. So in the case of a double, the sort of default initialization is going to be 0. So you'll have an array filled with zeros at the end of it. If you want to create a literal set of data values in the same way that you might initialize a variable with a literal string or with a literal integer, or with a single literal double. You can also initialize an array with an array literal. What's different about this is that we put curly brackets around it. And here we're using curly brackets in a slightly different way than the other way in which we use curly brackets. Previously, we've seen curly brackets used to block off compound statements, to block off sections of code, for example, that get run if an if statement is true, or to block off a section of code that is part of the while loop, or to block off a section of code that is part of a do while loop or a for loop. It's used to put scope around some blocks of code. Here we're using it in a different way. We're using it to identify the bounds of an array. In this literal, we're declaring that we have a new variable called more values. We're using camel case here because the V is capital and it's in a second word in the middle of our single variable name more values. It is an array of doubles, and we're initializing it with a set of doubles that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 long. So at the end of this, we're going to have an array of 10 doubles. When we're initializing this, we actually have a mix of different kinds of literals that we're putting into this array, but they're all going to get converted to doubles automatically if Java can do that. So for example, this first 32 here, by virtue of not having a decimal point, Java is treating that as an integer when we write it down. When it tries to store it in a double, it's going to do its best, if it can, to take whatever you're initializing your array with and converting it to the right type. Converting from an integer to a double is simple. You just put a 0.0 on it. It's really trivial, and so Java supports that. So we'll have 32, 54, 67.5. This is interpreted as a double literal from the get-go, so there's no translation that's going on here. 29, 35, 80, 115, 44.5, 165, 10 different numbers. That order is going to be preserved. This is a good example of that ordering I was talking about. 32 is going to be at the first position in our array, and 54 will be in our second position. Later on, we'll have 35 here in our fifth position, and that order is going to be preserved. But when I say that that order is preserved, I don't mean that this is in ascending order. I don't mean that it's in descending order. I just mean that the order that we put them in, it's going to stay that way and not change. If what I want is I want them ascending or descending, well, now I have to do some additional work to shuffle the order around. But whatever order things are in, part of the contract of a list is that order is preserved and that you can have doubles. So in this particular example, I don't have any examples of the same number appearing twice, but that is possible if you wanted to do that. All right, so now we're going to look at another way in which we can use those square brackets. We've looked at declaring our variable. We don't have any number in the square brackets. We've looked at initializing our variable. We put a number in the square brackets, right side and left side of the assignment statement. Now, once we've done that work and we want to work with it, we use this particular index in the square brackets in order to put things in and take things out. So we use the square bracket as an operator now. So if we have already initialized and declared an array of doubles called values, we can assign the index 4 to have the value of 35. In Java, all our indices are 0-based. So if we use index 4, we're actually talking about the 5th position in our boxcar. So it's as if values is a train that has 10 different boxcars in it, where the first boxcar is called boxcar 0, the second one is boxcar 1, so on and so forth up until the 10th boxcar, which is named boxcar 9 because we started at 0. In this case, we're going to empty out whatever coal was in the 5th boxcar, index 4, and instead of having whatever was in there before, now we're going to replace it with the 35. So we've lost whatever data was there previously. It's just been overwritten. It's gone. Possibly garbage collected, depending on the situation of what was there. That slot number, we call it an index. Each slot has some data that's in it. The data that's in it has to be matching the type of whatever our declaration of values was. Generally, we can use any kind of integer value in order to index into our array. So in the first yellow box here, we use a literal integer value of 4 in order to access into our array. But generally, we can also use variables. And most of the time, you will be using variables because you'll be using the array as part of some kind of an algorithm in order to access different positions in your array to execute some higher level work, to sort, or to find the highest thing, or to calculate the average, or to look to see if a particular element is present in your array. And then to do that, you're going to probably put your array in a loop, which is a very common pattern. And if it's in a loop, you can look at each element in turn by using a variable like we have here with variable I. You can also, if that first yellow box is how we put something into that location, we can also pull something out. We can evaluate values sub 4. I say that, look, I don't actually know if other programmers say sub 4 when they're referring to a location within an array. I've just grown into that habit. No one has ever corrected me. And I guess since I'm a professor, I now get to say that's right. So values sub 4 is how I speak when I'm talking about position 4 within an array. And so if you would like to know what is in the fifth position or index 4, you can write down values sub 4, putting 4 in the square brackets, and Java will evaluate values sub 4. It will change that. It will evaluate that first to whatever is stored in that position. So if we follow the logic of the slide, what's there is 35. And so the result of this will be to first evaluate value sub 4, which means reach into the array, get the value, and replace it with in your code logically, and then print out that number. So we should print out 35 if everything is working correctly. Here's just a visual example for those of you who need some visual reinforcement for what is happening. I'm a very visual learner, so I understand that. Our first step of declaring our array variable does something like box 1 here, where we reserve a variable name that will be a reference to our data that we store, that we have to get. Block 2 is the result of calling new double 10, right? So we have declared values. Now we use new double 10, and that creates this red box. It is filled with zeros. It has 10 slots. And then when we do the assignment statement, we pair values to that new double 10, and now we have a linkage between values and double. When we assign slot 4, or index 4, the value of 35, we overwrite the 0 that was previously there, as we see here in the blue box number 3, and we replace that 0 with the 35. And so at any point in the future, if we ask for position 4, we're now going to have 35, and the original value of 0 is lost to eternity, the mind of God, forever. Okay, so just to summarize, we've got an initialization of a type. We've got square brackets with nothing in it. And if we have that, we're declaring a type. And notice it's a different type. It's not a double. It's an array of doubles. We give it a name, and then we can initialize it with some blank data, which would be new, or we could use a literal, which is with square brackets. And then later on, when we want to use it, we use the square brackets with an index to either assign something to it or to retrieve something back from it. There are some subtle questions here that remain unanswered or that we haven't addressed. For example, what happens if the value of I is less than 0? Or what happens if the value of I is greater than 9? In both of those cases, Java is going to throw an exception. It's going to give you an array out of bounds error. Unlike Python, where you could use negative indices, and the way Python interpreted a negative indice was to work backwards from the end of the array. Personally, I think that's a really dumb idea, but Python disagrees with me. You cannot use negative indices, and you cannot use indices that are greater than the number of data points that you have reserved when you initialize your variable. And if you do, you'll get an error. And so in addition to declaring your variable, you also have to keep track of how much data you've declared in order to make sure that you don't run into some sort of bug. All right, so let me see if we have any questions of that. That's sort of a sprint with some information about arrays. Let's go to game and see what we've got going on. Oops. All right, while I was not broadcasting, we had two good questions. One was, can you have multi-dimensional arrays? And the other was, do arrays have to have the same type in them? And the straightforward, 90% answer is that yes, you can have multi-dimensional arrays. That's fairly easy. And no, you can not have more than one type in an array. There's nuances to those answers that are relevant and more I don't know in some situations. But the basic answer is as I said. All right, so let's see. Let's do, I'm just going to go ahead and start coding. And then for those of you that haven't connected with Saros yet, I will try and share that with you. If you want to stick around after class, I can share it with you after class, or we can just put it in Canvas. All right, so the first thing that we looked at was the ability to create an array. So here is a declaration of an array, and we have some values, and we can just declare it like that. And now Eclipse knows about a variable called values and knows its type. Now we saw that previously, and we've already looked at that. So let's do a different one. Let's do integers. Oh no, let's do something else. Let's do Boolean. That's kind of fun. That's an array of Boolean values. Let's go back and do an array of ints. That makes a little more sense. Or I can think of what to do with that better. All right, so now, all right, that's interesting. Let's go ahead and declare it. So that is our variable initialization. Now we need some memory so that we can store stuff in it. So we're going to use our new identifier. We're going to go back in time before we called constructors, before we knew what that was about. And we're going to declare a new array of integers. And at this point, we're going to pick a specific number. I'm feeling prime, so let's do 7. That's an array of 7 values. Now I'm getting a warning on line 7 because even though I have initialized values, I'm not actually using it at all. And Eclipse is like, hey, you declared this variable on line 7, and yeah, you're initializing it in line 9, but you're never actually doing any work with it. So you could just get rid of it all if you wanted to. That's just because I haven't finished my code yet. Oh, Eclipse, you don't know what I have in store for you. All right, so let's put some values in. Let's put some data in values, and so we're going to do that using a third way of the square brackets here. So look at our square brackets. We've got square brackets on line 7 used as part of a type declaration. So formally, this is the type. I put parentheses around it, not because it's good syntax, but to draw out what the type is. The type includes those brackets. That helps sometimes to understand that when you're visually parsing. Here, I'm using square brackets in order to initialize the memory for my variable. And now I'm going to use the square brackets in order to put something in there. I don't have to start, once I've declared that memory, I don't have to start at position 0. I can put my favorite number today, which is 14, turns out right now. My favorite number is 14. And you can see in position 5, index 4, I'm putting the value of 14. Notice that 14 is much greater than 7. That's because 14 is not an index, it's the data, right? 14 is like the coal. It's not like the address of the boxcar. If I were to do this, I would have a problem because this says I'm trying to store value 4 in boxcar 14, and there isn't any boxcar 14. There's only boxcars 0 through 6 available to me. If I wanted to store the value 4 in boxcar 4, that's fine. I can store the value 4 in any boxcar I want that I have initialized my memory for. So there's the lowest one, and here's the highest one, and I've put 4 in all of them. And let's put 5 into 1, into 5. All right. And for fun, let's do a little loop where we output all those for int I equals 0 while I is less than values. Haven't introduced this yet, but we'll go ahead and show it to you. You can get the length of a particular array by using the length. This isn't a method. This is like before we properly had objects, and so this is sort of a prototype. It's the paramecium of the array list. It is the Neanderthal of our array list, and so we have this thing called dot length, and it's this weird hybrid thing between a method and a variable name. It's not properly a method. It's not properly an instance variable. It's just left over from our primitive ancestry who joined us on rocky shores as they were crawling out of the primordial soup. Okay, and so I'd like to print all those out, and so I'm going to use the formulation here of using an index, a variable number for our index. How's that look? Settle down, Eclipse. Good. And then if I run that, and let's see if I can zoom in for you on the code. Whoosh. There you go. And let's look at the console. All right, you can't see it because here, let me, so that it doesn't, let me run that again for us so that you can see it on one line in the output. All right, so you can see that position 0 through 6, 4000414. You can see that that's what's happened up here. I overwrote position 4 that did have 14 with the value 4, and so that shows up here. I never set anything at position 1, 2, or 3, and so those remain 0. And I didn't get any errors because I never accessed anything that was outside that range. If I did something like this, Eclipse can just stop me right away. I think Eclipse will stop me right away. Oh no, Eclipse does not stop me right away. But if I try and run this, I'll get a runtime error. Boom, I got an error. If I look at that, it says what happened. Index -1 is out of bounds for length 7. So if you have some idea of how an array works, that error message is really helpful. And then if I want to know where it happens, I look here and it says, oh, hello world.java line 17. And in fact, if I click on that, it'll go right to where the error is, and it'll show me that. The specific exception that was thrown was an array index out of bounds exception. So there's a lot of information there about what went wrong. Likewise, I would get that same error if I used 7, because 7, although there are 7 elements in it, position 7 is one beyond the maximum position, which is 6. Index 7 out of bounds for length 7. So you just have to know it's 0 index for that to make sense. Faith asked a good question about if you can have multi-dimensional arrays, and you can. You can initialize an array like this. And then if you want to access particular elements, you just add an additional array element. So you can think of this as like X and Y if you wanted to keep track of a spreadsheet. These could be cells, this could be your rows and columns if you wanted. Again, you have to be careful about making sure that you have your bounds correctly set up. So here's an example. Here's a doubly nested loop, and just like assignment 6, I said you're going to need a doubly nested loop in order to be able to do a 2-dimensional array. We're actually doing a 3-dimensional, but you do need 2 for a 2-dimensional array. So to print this out, I want the outside. I want I to go the length of values, but then I want j to go the length of values sub I. Let's see if that works okay. Great. And then finally here, I want it to be I and j. All right, so it actually looks like a grid. I'm going to have it print out everything in a row there, and then at the end of the row, I'm going to print out just a new line character. All right, let me look at that for a second. Okay, that looks pretty good. Let's run that. All right, and then you can't quite see it. Let me give you the ability to see that. All right, so you should be able to see now that we got a little array out of the whole deal. So you can see position 0, 0 has a 4. That's right here. Let's do one more just so you can see the bottom right. I'm going to put something in the bottom right. That's going to be value 6, 6. And we'll give that a value of 999. And we run that again. And oh, what did I do wrong? Why did that not show up at the end of the block? Oh, because it's a 7 by 9, not, okay, that's what we want, 7, 8. I thought it was square, so I thought I was putting it in the bottom right. There we go. So 999 goes down to the bottom right. Okay, some good code for us there. Let me open the floor for any questions about what we just typed in. Any questions, double broadcasting? All right, marching on smartly. Okay, go for it. Go for it. All right, going to YouTube. All right, so the question was, how do you output a three-dimensional array? That seems challenging. It is challenging because we only have 2 dimensions to work with. So I got an error there because I didn't declare values to be a three-dimensional array, so I changed that and I added a third dimension. Let's make it 3 by 3 by 3 as if we were going to play a game of three-dimensional tic-tac-toe. Let's go ahead and put, let's put 0, 0, 0. We'll make that a 1. And we'll make 1, 1, 1 a 1. We would need another loop in order to get the third dimension out of there. We'll do I, J, K. All right, so we have to think about, well, what do we want to do here? Maybe at the end of our second block, we will just print a blank line. We could do that. So now we'll have a blank line between each dimension. Let's see, and I need another thing there. And I'm going to go under source and format just to make sure all my indentations are clean. You can see that when I did that, it cleaned up my little assignment statement, so it's easy to read. I love that. That's so great. Save that file and then run it. You can see that did not work out very well at all. That didn't give us anything that was helpful. So let's try that again. What did I do wrong? Oh, I'm sorry. When I put in that, on line 18, when I put in that additional curly bracket, I changed the logic that I intended. I intended the logic to be like this. And let's clean that up. There we go. Let's run that. That's what I intended. Great. So here's an example showing you on screen. This is what you could possibly look at a three-dimensional array. It's as if you're slicing off each layer. And then if you wanted to do four-dimensional, well, you'd have to start getting creative with indentations or something else. But maybe the console isn't the best place to do that. And you're either going to have to just think about it abstractly in a four-dimensional way, or maybe you'll use a graphics package like JMonkey Engine to sort of do something a little bit more different. But the problem of being able to represent 3 and 4 and 5-dimensional data is not one that's particularly unique to Java and the console. Like, how would a painter represent a three-dimensional object? Well, use things like perspective and shadow and shading in order to represent that for a painting. If you wanted to represent a fourth dimension, like how a cube changes over time, well, how would you paint that? Well, it'd be challenging. So it requires some kind of abstraction or maybe an animation, some other way of viewing it. So it is a challenge. Okay, let's make sure we're broadcasting okay in game, in the sense that we're not. Okay, and we are. All right, so just to clean up a few of those things, just to clarify, if we have an array of 10 elements, our first number is 0, even though we have 10 elements in it. And so our index can be, oops, and I'm not showing you the screen very well. And as a result, there we go. And as a result, the first element is value 0, and the last element is values 9. And it has to be 0 or greater, and it has to be less than the size of the array. And just another analogy that you could use would be like your mailbox. A mailbox has a number that identifies it, and that is like the index, and then it has the contents inside it. The letters are like your data. And so when we say that we have new double 10, it's like we have 10 mailboxes, although what we put into each mailbox depends on the type and whatever we assign it. and it doesn't have to be less than 10 by any means. All right, we saw a bounds error when we were doing the code. A bounds error simply means that we've accessed an element that isn't present in the memory that we have allocated. This is a runtime error, meaning that it's not detected at compile time, and it can be kind of a problem for debugging. So you have to be careful to make sure you're managing your array size correctly. We saw that in our code, but here's another example in line yellow. This is the most common one that you'll get, which is when you try and access the index 10 in an element that has 10 elements in it. That'll give you an error, and when you're first using arrays, this will strike you as very confusing and hard to debug until you remember that because we started index 0, there is no index 10, there's just index 9, which is position 10. I introduced values.length. It's sort of a hybrid. It's a hybrid of primitive types and our object-oriented way of operating. And so we can access how long an array is using this .length thing. It's sort of a unique syntax. It doesn't have a good generic way of describing what it is. There's no parameters that follow it, and there's no parentheses that follow it. And so it's just this kind of one-off way of figuring out how long an array is. We'll see it done better in an array list. Few aspects of it. The first row here introduces a new array of 10 numbers. That's what we did in our Eclipse demo. You can see that we could also use a variable to initialize the length of our array. That's what we're doing in the second row. We're declaring a constant called length and using that to declare the length of our array. In the third row, we're using a variable to declare the length of our array, and that's okay as well. It doesn't have to be a constant, but after we declare the array, the size of that array doesn't grow or shrink. Even if length changes on different runs of our program, in any particular run of our program, it doesn't change the size. Row 4, we're initializing an array of integers with integer literals. This is going to end up with an array of size 5. Index 0 is 0, and index 4 is 16. In the fifth line here, we have an array of strings. And again, we're initializing this array of strings with 3 different string literals, Emily, Bob, and Cindy, using our array literal syntax with curly brackets. Finally, in the final row, we have an error, which is where we try and assign an array of doubles with the memory that's allocated by new int 10. So we're creating an array of 10 integers, and we're trying to store a reference to that with something of the wrong type, and Eclipse, that'll be a compile time error because the types don't match. And what's going on in the computer in this situation is that an array of 10 integers actually takes up a different amount of space than an array of 10 doubles. And so not only is the space different, but the individual zeros and ones that are in that memory that's being allocated get interpreted different if you say it's a double than if you say it's an integer. So just generally speaking, that's not going to fly. All right, so our references, what we get from a variable is actually a reference. So recall how a reference works compared to a primitive type. A reference means that we can have aliases. A reference means that we can use multiple variable names in order to access the same data. And again, you can see that there's this trajectory moving towards an object-oriented world where all objects are treated as references. Primitives, no primitives are treated as references. And so here in this array list, we have this hybrid world. If we were to take an int, so if we were to take, let me go back to code here. Let me just find some space at the beginning of main. If we were to say int equals 5, int a equals 5, and we say int b equals a, and we were to say b equals 3, then the question is, what is a? Because we're working with primitive types and not references, a is going to still be 5. Let's just prove that. Ignore what I'm doing here. Okay, so we're just going to run this code right here to demonstrate what happens when we are not using references. Set a equal to 5, B equals A, so B gets a copy of 5. We set B equal to 3, but A is not changed. A is 5 and B is 3. The world is as we would expect it to be. But when we deal with references, it doesn't work the same way. When we deal with references and chunks of memory, I'm giving you a counterexample here. All right, so we know it gets initialized with 0. So if we say let's say if we say B sub 1 equals 3, the question is, what is A sub 1? Well, we should see that our change to, make sure this output looks correct. And we run that. Great. Okay, so what we're seeing here is that we allocate space for 2 integers. We say B equals A. When we were using integers, we made a copy. But when we use references, we're pointing at the same memory. So A and B are pointing at the same memory. So now when we change what is in position 1 on B, it ends up altering also what's in position 1 in A. And you can see that in the output because instead of getting 0, we get 3 in both cases. Just to reinforce that, if we make that 5, we'll see that we get 5 in both cases. Okay, so that's different. That's what it means to work with a reference rather than working with a primitive type. We modify scores, and we have a change to values as a result. So here's the exact same example with some different variable names worked out on the slide. Visually, we have one chunk of memory, and we have 2 references pointing to the same bit. All right, so let's see. Great. Okay, so just checking our progress here. All right. So I think what we will do next time, let me see. All right, I'll figure out how we're going to move forward. But this is a good chunk to have covered today, introducing the idea of arrays. There's kind of a couple concepts that I want to make sure that you understand, which is how to use arrays as parameters and how to do algorithms with arrays. So we'll look at some array algorithms, not all of the ones that are presented in the textbook, but a few of them. We'll look at how we can pass them as parameters, and then we're going to shift our framework to think about how we do a similar kind of work in an object-oriented way using not arrays, but something called array lists. I really prefer array lists. They do a lot of work for you. They do a lot of housekeeping for you. They're sort of a cleaner way of working with the same mental model of a list. There's a little bit more overhead. It takes a little bit more computational power for the virtual machine to keep track of them, but we have a surplus of computational power at our fingertips. So it's better for most applications, I would say. Okay, that brings us to the end of our time. Thank you for your patience. Let me shift over to game. So just to wrap up the broadcast, today is February 19th, Friday, CS-030, looking at arrays, chapter 7. Thank you for your attention. You're dismissed. I'll stick around in game to answer any questions. Thank you for your attention. Shutting down the broadcast.